Okay, let's look at solving two-step equations. Now is when it starts to get more and more important that you are able to use these inverse or opposite operations. Those are your verbs in math. You're adding, subtracting, multiplying, dividing, and so forth. So your opposite operations. Okay, so what you want to be thinking about again is kind of that balanced beam scale. You've got a left side and a right side of this equation that are right now balanced. And we're trying to do things to isolate the x. Get the x alone, or whatever variable, whatever letter. Get the variable alone. And we're going to do that by using inverse operations. This is when it starts to get more difficult to guess and check, so we really got to learn how to do these. Okay, so really what I'm going to do here is I want to combine like terms, but I can only combine like terms if they are on the same side of the equation. So in my first example here I have 1, 2, 3 terms. Terms are separated by minus signs, plus, equal signs. So I have a total of 3 terms. The two like terms are the -4 and the 17. So I want to get these two together. The problem is they're on different sides of this equal sign, so I've got to move it legally. So again, I'm thinking ahead. What side is the variable on? If it's more than one side, I might have a different decision to make. Right now I only have one decision to make. It's on the left. So the easiest thing to do is going to be to leave that 3x here. I want to move this -4 to get it with my 17. Okay, because I want x alone. Okay, so I'm going to do that by using the inverse of subtraction. I'm going to use the addition property of equality. Hold on. Jackson! Okay. Sometimes he gets a little needy. Alright, so I got 0 here, and it's going to leave me with 3x. Well, that's really what I wanted, because I wanted the x term alone. So 17 plus 4 is 21. And now I have one more step to get x alone. I want to get rid of this 3. The inverse or opposite of multiplying by 3 would be dividing by 3. So again, I'm using the inverse operation here. I'm using the division property of equality to solve, but I'm dividing the inverse of multiplication. And this becomes 1. 1 times x is x because of your identity property. So I've got x equals, and 21 divided by 3 is 7. And that's my solution. Now, remember, I want to always check solution. A solution is the value for the variable, the value that when you substitute into the original equation makes it true. So I'm going to come over here and check. 3x minus 4 equals 17. My x was 7, so I'm going to substitute 7 in for x minus 4. The right side, there's nothing to do here, it's just 17. Order of operations, parentheses first. Actually, this is not parentheses, multiplication. 3 times 7 is 21, and 21 minus 4 is 17. So my left side and my right side were equal, so I know it's right. I want to actually show you, if I have not shown you yet, if you have a graphing calculator, a TI 384, the safest way to check these is with the store key. So what I'm going to do right now is come back here. My solution that I got for x was 7. I'm going to take the number 7 and store. So you've got this key down here, stow. I'm going to put that into store into my variable x. Now I can use this key right here for x. Okay. Now that I've told the calculator what x is, I'm going to just enter the left side and make sure that I get the right side, which is 17. So 3x minus 4 is 17. So this is a really great, safe way to do it, especially if you've got negative numbers and you're squaring things. It starts to get a little tricky entering in the calculator. So I strongly recommend learning how to use that store key. Okay, so let's look at the next example. Okay, this time I want to throw a fraction in there, in case we hadn't seen an example like that yet. So again, I've got my left side and my right side of the equal sign here. My variable w is on the left side. I have a constant term 1, and a constant term here is 9. So I'm going to, again, want to get these two constant terms together, and I have to ask myself, what do I want to move? What makes the most sense to move right now? Well, I want w alone. I only have one term right here with w. It's on the left. So let's leave it there. Let's move this 1. So the opposite or inverse of addition is subtraction. My subtraction property of equality says to keep it equal, I have to subtract both sides. So here I get 0. My identity property of addition says if I add 0, that's not going to do anything. So I'm just left with 2/5 of w equals 9 minus 1 is 8. Okay, so I have one more step here to solve. This is the inverse property of multiplication. When you take a fraction and multiply by the reciprocal, you get 1. So when you turn the fraction upside down. If you remember your operations on fractions, really this is a number times w. So the opposite of multiplication is division, but your rules with fractions are when you divide by a fraction, you're really multiplying by the reciprocal. Turn it upside down. So 5/2 times 2/5 gives you 1. Now, your multiplication property of equality says if you multiply the left side by 5/2, you have to do the same to the right side to keep it equal. So this becomes 1 w. 1 times w, your identity property says that's just w, equals, and on this side I have 8 times 5/2. If you're not sure how to do this by hand, use your calculator if you are able to use that on whatever assessment you're taking. But if I put this over 1, remember 8 is in the numerator, 2 is in the denominator. So usually what I do if I can is 8 divided by 2. I do that first. So 8 divided by 2 is 4, and then that leaves me with 4 times 5, which is 20. Now I want to check and make sure that my solution is correct. I can't fix my problem if I don't know that I have one. So I'm going to come off to this side and I'm going to check. The original equation was 2/5 of w plus 1 is equal to 9. And I'm going to substitute 20, my solution that I got here, for w. And I want to see if the left side and right side are equal. The right side is just going to be 9. There's no work to do there. 2/5 of 20, again, 20 is over 1, so 20 divided by 5, 4 times 2, 8. And 8 plus 1 is 9. So 9 is equal to, my right side was 9 already, and that's my solution I'm checking. Again, if we do that with the calculator, if you have not seen before, you can, on these graphing calculators, there's all the letters. In this particular model I have, they are in green. So see all the alphabet, the letters in the alphabet are here in green. So if I want to access those, I have to go to my green key, which on my calculator is alpha. Okay, so alpha, and then I go and I find the letter W, which I was search is right here. Okay, and right now my calculator thinks it's 0. So remember, if you're going to check with the calculator, you have to tell the calculator what you want the variable to be. So I'm going to take 20 and I'm going to stow into alpha, and I got to find my W again right here. Okay, so I'm putting 20 in for W. Alright, now I'm going to put the left side of the equation, 2/5 times W plus 1. Remember, you always go back to the very beginning with the problem they gave you. And the right side, there's nothing to enter. It's just going to be 9. So hopefully I get 9. Okay, so I've checked that solution. All right, one more. And this example actually is a little bit different because this time I still have 3 terms, 1, 2, 3, but this time it's the variable terms that are on both sides. All right, I'm not doing anything different than what I did in the last 2 examples. I want to combine my like terms. I want to get the y's together. Now, if I think ahead, I might save myself a little time. I want these two together, and I want them on the opposite side of my constant term. So right now, negative 3 is on the left. If I move the 7y, if I move that over here, then everything's on the left. I'm not really working towards my goal. My goal is at the end of this problem, I want y equals a number. So I want to get the y terms together, and then I want to get them alone. So again, if I move this over to the left, everything's on the left. Right now I have a constant term, negative 3 on the left. Let's move the 6y. It's going to be faster. So the opposite of adding, this is positive 6y. The inverse operation here would make 0. So 6y minus 6y is 0. Your subtraction property of equality says, okay, we'll do that to both sides if you want to keep the equation equal or balanced. So here I've got 0. Your identity property says, well, yeah, adding 0 doesn't mean anything. Be very careful here. Whoops, black. Be very careful here. You have a minus, but when this goes away, that really becomes a negative. So we have negative 3 equals, and 7y minus 6y is 1y, or y. 1 times 1, and the identity property says that's y. Okay, I know it looks kind of funny because you've got your variable backwards. There's no reason why you can't switch sides. This is the symmetric property of equality, if I remember correctly. Okay. So I want to check my solution. I go back to my original equation, 6y minus 3 equals 7y. I'm substituting the solution I got, negative 3, in for y, on both sides here. So this is 7 times y, which was negative 3. Okay, so I'm going to do this with the calculator as well to show you the store key, but 6 times negative 3 is negative 18, multiplication first, and then I combine the like terms here and I get negative 21. And then on the right, a positive times a negative is negative. 7 times 3, 21. So my left and right side were equal, so I'm checked. That's correct. Now I just want to make sure, 100% sure, this is a negative value that I found. These can be tricky by hand, so I would check with the calculator. So I'm going to tell the calculator that I want to make y negative 3. So I put the number first, store into y. Okay, negative 3 is now in there, and I'm going to go back to my original equation. I'm going to enter the left side, 6y minus 3. Enter, and then I want to make sure, I'm going to put in the right side, 7y, and make sure I get the same thing. Okay, both sides were equal to negative 21, so check.